colour, and it's a good introduction to science for very young children. I always started with the primary colours, pigment primary colours, blue, yellow and red. I used colour paddles to demonstrate the colours. First of all, I would hold up a blue paddle. Transparent film colours are good as well, but I would use colour paddles. They're easier to transport. I ask the class, what colour can you see? And I hold up, I get the answer, always right, blue. Then I hold up yellow and I say, what colour can you see now? And slowly I say, what colour would I get if I mixed the yellow and the blue? And I slowly mix them and hold them to the light again. And as you see, it makes green. And I would pick up a red paddle and a yellow paddle. I would ask, is that red? Yes. What colour would I get if I mixed red and yellow? And I'd slowly overlap and make orange. And the last one, of course, is what colour would I get if I mixed red and blue? By this time the children are all quite enthusiastic and most of them know the answer. And you mix it and you make purple. Now you see, that's all the colours in the rainbow. Let's try and make a rainbow. You choose 4 children from the class and give 2 of them blue paddles. 1 of them red and 1 of them yellow. You ask the children to stand in a row and the blue ones are at the end of the row. And the yellow and then the red, just like this. And the children are asked to hold up the paddles high in the air, in a nice light air. And you get them to overlap their paddles like this. You just tell them to overlap the paddles until they can make a rainbow. They can just adjust it until the class tell them they've made a rainbow. Quite complicated, but the children can do it. Let another 4 children try as well. And then they get the idea of how to make a rainbow and how colours are mixed, which is quite a good practical experiment. But then you see, that's what you use. You mix colours when you're colouring in and painting. But if you're doing science, you can also separate colours. And if you separate colours, scientists can solve problems by doing this. I'll show you an experiment about separating colours and solving a problem. The experiment is about solving this problem. Which of those 2 pens is a mixture of those colours? Only one of the pens is that exact mixture. Can you guess which one it is? Hopefully the class will divide and some of them will say the light pen and some of them say the dark pen. You point it out that one is a light colour and one is a dark colour. And you say, well, let's do a science experiment and investigate it. Each child gets a dish. It's a petri dish really, with a hole in the lid, a slit in the lid. They also get a pipette. Now they'll never have used a pipette before, but it's very cheap and very simple to use, and the children do like doing it. First of all, you see, you'll try and lift water with the pipette. Now the instructions are all on the leaflet. If you buy the kit, you'll get all the instructions, but I'll demonstrate it first. Now you ask the children to dip the point of the pipette under the water, and you squeeze hard and get all the bubbles of air out of the bulb at the end. Then you let go and it lifts up the water. Squeeze it out again, get rid of it. Try that at least 3 times until you can get it nearly to the top, and squeeze it out again. Try Tie it again, right up to the top, squeeze it out again. Now you'll probably get a few children who squeeze it out all over each other, but it's just water, not wipe up. Now, the next time, pull it up, take the lid off the dish and squeeze the water into the middle of the dish. Put the lid on again. Then you take a piece of paper. It's special paper, it's called chromatography paper. A strip of paper each. Now the children will have chosen one of the panes, so they get a choice. You divide the class into the light colours and the dark colours, and you circulate the panes round. Now we'll say we're in the light colour. You've got to measure. Science is always about measuring. You've got to measure where you put the dot on the strip of paper. So you put 2 of their fingers at the very end of the paper, and where the fingers end, make them do a nice big inky dot and pass the pen to the next person. It doesn't take long. Then you drop the piece of paper into the water and it'll slowly climb up. Those are some experiments I did earlier. That was a yellow pen. You let the water climb through the ink, and as it climbs through, it makes it smudgy. And sometimes, nearly always, it separates the colours in the pen. This is a chromatogram that I did with the brown pen. And look, it's got blue, red and yellow in it. Now that's one. Now here's one I did with the orange pen. Now orange, as we saw earlier, is made of yellow and red. So the orange divides to the yellow and red. Now this was a dark red pen. The dark red pen divided into pink and a space, I don't know why, and orangey red. It's intriguing really to find out just what happens. The purple divided into a sort of reddy and a blue, just as it ought to have done. Point out, well, if you're doing this, yellow is a primary colour. It's not a mixture of anything else, so you won't get anything dividing out of the yellow. Blue is the same. It's a primary colour, so it just comes pure. And what's red? Red. Oh, now the red was a slight cheat, I'm afraid. The red, you've got red, but it's a light red, so you've got a bit of pink mixed in this dark red pen. This is the pink pen, so it's the same pink. As you see, you can do a lot of investigations with colour. Now, this one is working quite nicely, but it's not exactly the same as that. It's not got enough blue in it. We'll have to let it run further up the paper. But the children will be watching each other's experiments, and they can have quite a few colours running at the same time. When the water reaches the top of the paper, it takes about 5 minutes. Talk to them about colours and colour mixtures while they're working with it. And tell them about the other experiments they can do. They can find out if a green pen is a mixture of what, when they fill it in, and a purple pen. Now a black pen, we haven't done a black pen. A black pen is a mixture of all the colours in the rainbow. Really dark. And as you see, the brown pen is a mixture of all the colours in a rainbow. Black and brown are called tertiary colours. They've got at least the three primary colours in. With black you would get a bit more blue and red and a little less yellow. But with brown you have quite a lot of yellow. But it's a good investigation. Now if the children ask, why does this happen? And with the older children, you'll get some bright ones who do. You tell them it's all about solubility. It's the solubility of certain colours. The colours in this pen, the red pen, the dark red, the true red, was very soluble. It moved further up the water than the pink. It didn't move right up to the edge. So it's solubility, which can lead you onto another experiment. Get some sugar and get some sand and see if a little dab of sand will disappear in the water in the dish. And see if some sugar, try using icing sugar, it's best, will disappear in the water in the dish. Just a pinch, not much. And you'll find that the icing sugar vanishes and the sand just stays there. And you can just see, well, that's because the sand is not soluble and the sugar is soluble. And that is the difference between the dark red and the light red. All the other pens have soluble colours. And that's the end of the experiment. And we've divided this. I haven't left it long enough. But as you see, you've got a blue and a yellow coming through. If we let it go right to the top, it would completely separate. But this one has got more blue in it, as you can see already. The light pen doesn't have as much blue as the dark pen, and that's what makes the colour dark.